Hi everyone, my name is Tayanne Ligeiro and I am a member of the FunWalks project as a PhD student. Today I will talk about the investigation on the effects of macro and micro paraffin ratio on the thermal and rheological behavior of waxy motor oils. This work was made by me, Letícia Ivanei Pinheiro, Charlie van der Geest, Antônio Carlos Bannwart and Vanessa Guersoni. Starting with an introduction, as we know, the crude oil production under low temperature favors the wax deposition in pipelines. So the challenge is to improve the prediction models and the mitigation techniques for this type of phenomenon. The goal of this study is analyze the effects of the composition of the oil in the rheological behavior, thermal behavior, and the morphology of the crystal formed by different compositions. So in crude oil, we have two types of wax. We have the macrocrystalline wax and the microcrystalline wax. They have different molecular structure, so this impacts in the formation of different crystals. The microcrystalline wax have higher molecular mass and crystallize at higher temperature, and the molecular structure impacts on the formation of smaller and rounded crystals, while the macro one form like noodles shapes. So the morphology impacts in the formation of different network. So the strength of the network formed depend on the morphology and the size of the crystals. So the type of wax present in the oil impacts in the rheological behavior. For this study, the methodology that we use is we analyze motor oils composed by solvent and wax. All the mixture was made with 10% of wax in different proportions of macro and micro. So we have until 10% of macro to 10% of micro, and with different proportions of macro and micro. Before the analysis start, the samples were kept in the oven for at least 2 hours in 7 degrees to erase the effects of thermal history. And we analyze in different methodologies these motor oils. We did the rheology in rotational and oscillatory tests. We did the DSC, the differential scanning calorimetry, to analyze the wax appearance temperature. And we also analyze the morphology in the microscopy. Going to the results, here we have in the first figure an rotational rheology, and in the second figure we have oscillatory rheology. All the tests we did in constant cooling rate of 1 degree per minute. So in the first figure we can see in the pink curve we have the changing of the rheological behavior in higher temperature. If we compare with the blue one, the blue is the macro and the pink is the micro one. So here we have the micro changing the rheological behavior in higher temperature because we have the formation of the crystals in higher temperature. But we have in the lower temperature that we analyze, the viscosity of the micro one is lower than the macro one. This is the final crystal structure of the macro wax is stronger than the micro one because of the structure of the crystals formed. We also see in the first figure that the composition of the oil, the proportions of the macro and the micro one impacts on the rheological behavior. We have different viscosities and different stronger networks for more concentrations of macro one, but we see that when we have more micro one, we have the formation of the network in higher temperature because of the concentrations of the micro one. And in the second figure is an example how we define the gelation temperature. We define in the oscillatory tests, and for us the gelation temperature is when the storage model is equal to the loss model. So here in this example of the mixture of 5 and 5, we have here 5% of macro and 5% of micro 1 is around 30 degrees, the gelation temperature. Now analyzing the results showed in table 1, we have all of these properties analyzed to all the mixtures. First, we analyze the gel temperature. We have here higher gel temperature to the micron. This is the elastic behavior grows faster in the micro than the macron because we formed the crystals earlier in higher temperature if we compare with the macron. And we have to the wax appearance temperature, same idea. In the micron we have higher molecular weight, so the crystals appears in higher temperature. But if we compare the wax appearance temperature and the gelation temperature, we have the difference between these two higher in the micron if we compare the difference in the macron. This occurs because based on the percolation law, we have the aspect ratio inversely proportional to the solid fraction required for gelation. That is, the solid fraction needs to form a strong network higher in the micron if we compare with the macron. We believe, and the results show it, that the combination of different types of wax impacts on the crystal formation, and this is one of the causes of the weaker network on the mixtures, as it's clear in the results on the wild stress. When we have the macro without micron, we have higher wild stress if we compare with the mixture of 9% of macro and 1% of micro. So the addition of 1% of micro impacts on a considerably reduction on the wild stress. So this is clear to the type of wax impacts on the weaker network of the mixtures. Now the results of microscopy. Here we have all the results for the samples under the temperature of 20 degrees. And here we have the macron with noodle shapes and higher aspect ratio. If you compare with the micron, there is lower aspect ratio. And here the crystals are more rounded if we compare with the others. And we also can see in the mixture the presence of the impacts on the micro impacting on the formation of the macron, because we can see that form like islands, and these islands make it difficult to form a structure network of macrons. This could be one of the possible reasons that why the gel strength is reduced in the addition of the micron, the interference in the formation of the macron. To finalize the conclusions of this work, so the micro-wax presents a nucleation action, increasing the temperature at which macro crystals appears. Also, the kinetics effect caused by the micro-wax interferes in the aspect ratio of the wax crystals and consequently modifies the rheological behavior of the gel. And the increasing of the micro-wax concentration impacts on the reduction of the gel strength, reduction of the final values of the loss model and the storage model, and the wild stress too. So with this study, it was possible to relate the rheological responses and the beginning of the formation and gel strength, helping to investigate the behavior of the deposit and improving the model and predictions models and the mitigation analysis too. I want to thank you all for the attention.